Let's look at one final optimization problem. So we're going to look at the following example. I say 2 posts, one 12-foot high and the other 28 feet high. Stand 30 feet apart. They are to be stayed by 2 wires attached to a single stake running from ground level to the top of each post. Where should the stake be placed to use the least amount of wire? So here's the picture, kind of set up this. Here I have a post that is 12 feet tall, and then I have another post that's much taller. Here's my second post. It's 28 feet tall. And in total, they're 30 feet apart. So the distance here is 30. And then there's a stake somewhere between them. And I'm running wire up to the top. Here's wire, and there's wire up to the top of the post. So I need to know how much wire is used on each piece, so let me use variables here, y and z, for those. So if W represents the wire length, then I'm trying to minimize W, which is y plus z. Now, I need to know this distance here. I'll call this first distance x, and that first triangle. Well, if that whole distance is 30, then this missing side right here, this is 30 minus x. So now I have some constraints. So what are my constraints going to be now? Well, if you look, you have right triangles. So we have the Pythagorean theorem. So x squared plus 12 squared equals y squared. And then in the other triangle, well, let's start with this first constraint here. If I solve for y, it's going to be the square root of x squared plus 144. And my other constraint is that 30 minus x squared plus 28 squared equals z squared. If you solve for z now, z will be the square root. And if you FOIL this part out right here, group up your like terms, you'll get x squared minus 60x plus 1684. So these are my two constraints, which I can then plug in into my function I'm trying to minimize, and I'll have a single variable now. Now remember, what here is going to be our domain for x. X is between 0 and 30, just based on this picture. So w, remember it's y plus z, so w will be the square root of x squared plus 144 plus the square root of x squared minus 60x plus 1684. And x is between 0 and 30. So now we're going to have to take the derivative. We're going to have to find our critical numbers, which means we're going to have to find the derivative now. So what will dw dx be? You're going to have to use the chain rule on these derivatives. So you'll get 1/2 and then x squared plus 144 in the bottom times the derivative of the inside, which will be 2x. And then you'll get a 1/2 here, square root the derivative of the inside, which will be 2x minus 60. So I can cancel here. I can factor a 2 out of the top. So if I factor a 2 out here, that'll bring this down to a 1 and a 30. Okay. And so now I want to set that equal to 0. X over this square root plus x minus 30 over this square root. Set that equal to 0. And if I move one of the terms to the other side, I'll get a negative, so then it'll be 30 minus x. And then if you cross multiply x times that big square root, times the square root. So again, I just cross multiplied here. Now if you square both sides, you'll get x squared, and the square root will go away. 30 minus x squared. If you square this, the square root will go away. So now if you multiply this out, you'll get x to the 4th minus 60x cubed plus 1684x squared. If you FOIL this out and then multiply with what's here, you should get x to the 4th minus 60x cubed plus 1044x squared minus 8640x plus 129,600. And if you move all the terms over to the left-hand side, you should be left with 640x squared plus 8,640x minus 129,600. You can factor out a 320, and then you should be left to factor what's left as x minus 9 and 2x plus 45. So I get two solutions. You'll get x equals 9 and negative 22.5, but x can't be negative, So we'll throw that out. So our only critical number is x equals 9. Now if you go back to W, plug in your endpoints, plug in 0 into W, you'll get approximately 53.04. If you plug in 9, you'll get 50. And if you plug in 30 in place of x, you'll get approximately 60.31. So if I look, I was trying to find the minimum. That corresponds to right here. So what's the answer? The stake should be 9 feet from the 12-foot pole or post.